Hey everyone, so today we're diving into object-oriented programming, or OOP, but let's just forget the dry textbook definitions for a minute. Instead, I want you to think of OOP as a creative toolkit, a way to go from a simple blueprint in your head to building entire living worlds with your code. All right, let's get into it.
To really get this, let's try a little thought experiment. Imagine every program you write is a story. Well, if that's true, then who are the characters? Right? Who are the heroes, the villains, the little helper droids? Object-oriented programming is what lets us actually create them.
You know, the absolute core of OOP, the big idea, really just boils down to one simple, powerful analogy. It's all about the difference between a plan and the actual thing you build from that plan.
So first up, you've got the blueprint. In OOP, we call this a class. Now, a class doesn't really do anything all by itself. It's the design. It's the schematic that defines all the properties and all the capabilities of something you want to create later. It's just the idea.
And then you have the object. This is the real thing. It's the thing you actually built using that class blueprint. It's a specific, tangible thing that's now alive in your program, and it has its own unique data.
And this right here makes it crystal clear. The class is the general concept, the car design, but the object? That's your specific red Tesla Model 3. You see? From that one single blueprint, you could create millions of unique car objects, and each one would have its own color, its own VIN number, its own story.
So how do we actually make one of these blueprints in code? Well, in Python, it's super simple. We just use the class keyword. And every good blueprint needs a set of instructions for how to build the thing, right? That's exactly what this special underscore init method does. It's the constructor. It basically tells the program, hey, anytime you build a new object from this blueprint, here's the information you need right at the start, like the car's make and model.
Okay, so we've got our characters, our objects, but a character with no personality is pretty boring. So how do we give them their own unique traits and personalities? In OOP, we use variables, but there are two different kinds we really need to understand.
Just think of it like this. Instance variables are unique to each and every object. So if our class was student, your name would be an instance variable. It belongs only to you. But a class variable, that's something that's shared by all the objects made from that class, like the name of the school you all go to. So one trait is totally personal, the other is communal.
Now this is where OOP starts to feel a little bit like magic, because we don't just create these lonely individual characters. We can actually create entire families where traits get passed down and new specialized behaviors start to emerge.
We do this with something called inheritance. And honestly, it works exactly like it sounds. A child class can inherit all the features and all the abilities from a parent class. This is so powerful for reusing code and building out logical relationships. For instance, you could have a really general parent class called animal. Then you could create a child class, dog, that inherits from animal. That dog automatically knows how to do everything an animal can do, but you can also give it its own special dog behaviors, like a bark method. It's just a more specific version of its parent. So cool!
Okay, here's a fascinating question for you. What if you have a bunch of totally different kinds of objects, but you ask all of them to do the exact same thing? How do they each respond?
The answer is this really powerful concept called polymorphism, which literally just means many forms. I mean, look at this. The command we're giving, .flypop, is identical for both the bird and the airplane objects. But each object knows how to carry out that action in its own unique way. The result, completely different behaviors. Same message, totally different outcomes.
All right, we have our characters and their families. Now, let's give them some secrets to keep, and maybe a few hidden superpowers that'll make them work perfectly inside our Python world.
I know, this sounds a little dramatic, doesn't it? But it's actually one of the most important principles for writing safe, reliable code that doesn't just fall apart. We need to be able to protect our object's internal data from the rest of the world. This idea is called encapsulation. Think about a bank account object. You would never want some random piece of code to be able to just reach in and directly change the balance, right? Of course not. So you make that variable private, and you force all changes to happen through controlled methods, like deposit or withdraw. It's like a protective shell, and it's what stops your software from being a fragile house of cards.
Here's a little puzzle. You just created a brand new type of object that's never existed before, maybe a book object. So how on earth does a built-in Python function like print have any idea how to display it in a way that a human can actually read?
Well, the answer lies in Python's magic methods. As you can see on the left, without one, trying to print your object just gives you this useless, confusing memory address. But if you define this one special method called __string __, like on the right, you're telling Python exactly how you want your object to be represented as a string. You're literally giving it a voice.
And it goes even further by defining another magic method, __len. You can actually teach the built-in len function how to work with your custom object. So now, when you ask for len my book, you don't get an error. You get the right answer, 350. You're basically weaving your own creations right into the fabric of the Python language itself.
So, let's just take a step back. We've covered a ton of ground, right? We've gone from a simple blueprint to creating objects that have families, that have secrets, and even have superpowers. You're no longer just writing lines of code. You're becoming the architect of a whole system.
So here it is, your core OOP toolkit. You've got classes and objects, the blueprints and the final creations. You've got instance and class variables to give them unique and shared traits. You can build entire families with inheritance and create flexible behaviors with polymorphism. And you can protect their data with encapsulation and give them superpowers with magic methods.
Look, these aren't just abstract academic concepts. These are the fundamental building blocks for creating code that's structured, that's reusable, and it's genuinely powerful. This is how you model the messiness and complexity of the real world inside your code. So the only question that's really left is, now that you have the architect's tools, what world are you going to build?